Hey, so I'm going to talk about what happens if you have a region which is neither type 1 nor type 2. And you want to do a double integral over it. So, for example, let's say you had something that looks like this. Well, this is neither type 1 or type 2, right? Because it's not a graph here. It fails the vertical line test here. It's not graphical. That's what type 1 or type 2 means for double integrals. I mean, this is R, just to recall what we're doing here. This is R. We want to do this double integral over R. And what we have, the problem is that R is just kind of nasty looking. So it fails the vertical line test there. And it also fails the vertical line test here. So you can't write it as a graph even if you flip it. So this is not type 1 and this is not type 2. So what do you do? How do you evaluate this thing explicitly? Well, just to illustrate, I'm gonna make the region a little simpler. And what you do is you basically chop it. Like, because you can split you can split any region and just into R1 and R2 and just do an integral over R1 and add it to the integral over R2. And you get something if this is easier just to split it up. So what we do is we split this integral up, and I'm going to just indicate a heuristic for how to do it, for which way to split it. So the split heuristic. What you do is you make the wiggly edges your graphs. So the flat edges, and you want to add more flat edges. Flat edges are good. So this is a wiggly side. Here's another one. So we want these to be the graph boundaries. So if this is wiggling, it's wiggling in the x direction, and this is wiggling in the y direction. So we'll want this to be a y boundary, and this one to be an x boundary. So what you do is you just draw a vertical line somewhere in a good location. So here, this would be a bad location on the left to draw a vertical line because you haven't chopped off the wiggly x part from the y part. So what you want to do is chop off something like right here, or even better, right here. So if you do it right there, now it satisfies the horizontal line test. Right? So it looks graphical now. So we've now split this region into two regions. Let's see if I can reproduce what I drew. It looks sort of like this. This is your R1, and over here we have R2. right? So I mean, you could sort of imagine this is sine of y, and this is sine of x, roughly speaking. But now this is a good old type 1 region, this is a type 2 region, and you can evaluate each of these things explicitly, at least insofar as you can, by splitting up your integral. So that's kind of the idea whenever you have a bad region, you just chop it. Okay, thanks for watching.